Okay, so we're coming up towards the end of chapter 4 and the end of the first half of the semester. And so in the first half of the semester, we've been doing differentiation. Okay, so we've been looking at change. So we've been thinking of the derivative as a slope. We think of it as a marginal thing. So like marginal cost, marginal revenue. But you can think of anything as a marginal, right? So what you get when you do an extra unit. Okay. We also think of it as a multiplier. So we have like an equation that gives us change in one thing, and in terms, so the change the output and change in terms of the change of the input, right? So saying the derivative is 5 means like if you put in one more input, you get 5 more output. Okay, so what we're going to do this week is we're just going to kind of finish up looking at a few topics from differentiation, and then when we get back from the break, we're going to look at the other bit of calculus, which is integral calculus. And so instead of in differential calculus, we break things apart. Well, in integral calculus, we integrate, which means we put things back together. And so we'll see how one is goes with the other. Okay, so the topic I want to talk about today comes from economics, and it has to do with change. So somehow it has to do with derivatives. So let's have a look at that. So let's have a look at the following situation. Let's compare milk and trucks, let's say. And we have a price. So let's say the price of milk is $2 per unit, and the price of trucks might be $40,000 per unit. Okay, and we sell a certain amount of these things, right? So maybe we're selling 1 million units of milk, and we're selling 10,000 units of trucks. Okay, so what we're interested in is how does price changes affect the quantity sold? Okay, so we might have a delta P, and we look at the delta Q. Okay, so milk, let's say if milk goes up 5 cents, then maybe we sell 10,000 less units of milk. And maybe if we add, I don't know, $750 to the price of the truck, we lose 1,000 sales. Okay, have you guys done this kind of thing before in economics? Okay, so what we want to do now is we want to compare milk and trucks. Okay, so I mean, you know, the cliche is, you know, you can't compare apples and oranges or whatever, you know, but actually apples and oranges are pretty easy to compare. Milk and trucks, not so much, right? So milk is kind of like an everyday household product that you have in your kitchen. You go to the store and you buy milk once a week. Truck, you know, maybe you only, you know, it's like a rare purchase, like maybe every, I don't know, 5 years or something, you get your truck, and it's once and well. Okay, so they really are hard goods to compare. So how do we go about comparing them then? Does anyone know the answer to this story? Okay, well so straight away you can kind of see that, you know, we've got 5 cents here, $750 here. You know, the price seems minuscule for the milk and really big for the truck. So somehow we've got to compare those things. So the standard way to do that is, instead of doing absolute change, we look at relative change. Okay, so relative change turns out to be useful in these cases, because what we're going to do is we're going to look at percentage changes. Hang on, let me blank this out. So let's say we're looking at that's how you would compare different markets, how you would compare different goods, right? So you're saying, are we doing better in Albuquerque than we are in Dallas? Well, and we might have more in Dallas, but say we rise by 10% in Albuquerque and 3% in Dallas. And in a sense, the person in Albuquerque is doing a better job, right? So relative change is a good thing to be able to compare across different situations. Okay, it gives a much more kind of fairer way of doing it, right? So you can compare different goods, you can compare different cities, you can compare different sports, you can compare different whatever. And so instead of saying, the raw quantity, which really does not make any sense to compare, right? So $3 here is not the same as $3 over here, but percentage change is something that you can compare. Like 2% is twice 1%, right? It's the same, you put things in terms of the same quantity. So let's have a look what happens when we look at relative. Well, remember what the formula for relative change is? So if absolute change was delta P and delta Q, the relative change is delta P on P and delta Q on Q. And so that gives you a proportion, which if you then multiply by 100, gives you a percentage. Okay, so let's have a look. What's the relative change in price? Well, a 5-cent rise in milk is a 2.5% rise for milk, whereas a $750 rise is, someone do 750 divided by 40,000 for me, please. Oh, I know what. I'll change this to 800, then we can do it in our head. Okay, 800 divided by 40,000. Right, 2 zeros go, 8 goes into 450. So this is a 2%. Okay, so we see that actually the changes in price are kind of comparable. Okay, well, what about the change in quantity? Okay, 10,000 divided by 1,000,000 is 1%. Oh, I should put a minus, right? So we see that a 2.5% rise in the price of milk leads to a 1% decline in the demand for the good. Okay. Whereas for the truck, minus 1,000 divided by 10,000, oh, that's minus 10%. Okay, so what was really opaque over here now sort of becomes crystal clear when we look at it like this, doesn't it? So we're saying that a rise of 2.5% in milk price only leads to a 1% fall in demand, whereas here a 2% leads to a 10% fall. Okay? So we see that the truck market is much more sensitive than the milk market. Okay, so that gives us actual real information that anyone who is actually selling milk and trucks would want to know, and maybe the people in charge of the markets want to know. Okay, so this is a topic in economics. What do we call it in economics? This kind of study. Anyone remember? Huh? Elasticity. So has anyone done this? Yeah, okay. So it's a pretty standard thing that you do in economics. Where do you do it in economics? Is it?
I'm doing it in microeconomics.
Microeconomics, okay. Okay, so straight away we can see that this is something to do with change. So if it has something to do with change, it has something to do with derivatives. And we can kind of see derivatives in here kind of sneaking around somewhere, right? Because we've got delta P and we've got delta Q. And so we know that's what we need to make a derivative. Okay, so let's have a look at things. So what we do is we look at the ratio of the relative changes. So what we do is we look at relative change in demand divided by relative change in price. That's going to be the thing. I mean, because you might naively think that, like if the price goes up 2.5%, will the demand go down 2.5%? But we know that it's a little bit more trickier than that. This ratio here, is this ratio going to be positive or a negative ratio? What happens when price rises? Does demand go up or down? So the price of something goes up, is there more demand for it or less demand for it?
Less demand.
Less demand, right? So this is going to be a negative quantity. So let's put absolute value signs there just to make everything positive. And we're going to call this quantity E for elasticity. And then we're going to see in a little bit what's elastic about it. Okay. So E equals absolute value of relative change in demand. Well, that's delta Q over Q. Relative change in price is delta P over P. Okay, so we want to change this into a derivative. So how can we get a derivative out of this? What do we need to have a derivative? So we want to do some algebra here to turn this in. Well, Before we do derivative, let's just do some algebra. So we've got a fraction divided by a fraction. So what does that equal? So here's a numerator, here's a denominator. Where does the delta P go into? So we've got delta Q over Q. So where does the delta P and the P go to when we put it all over a numerator over denominator? Yeah. So down here, the denominator in the denominator becomes the numerator, right? So that flips over. Okay. And now we do one tricky bit, which is just to swap this order. So we get delta Q over delta P times P over Q. And now do you see the derivative? The derivative is here, delta Q over delta P. So our definition of elasticity then is going to be the absolute value of dq dp times P divided by Q. And that's where the derivative is. Okay, great. So we've seen that elasticity, as we suspected, is something to do with derivatives. Okay, now a derivative, remember how we think about it. We think of derivatives as slopes. Well, it's hard to see anything to do with slopes here because we haven't got anything graphed. Okay, but we think about derivatives as kind of like a multiplier or something marginal. So here, what is the elasticity a multiplier of? Okay, so is it? Well, it gives us, so remember we've got this thing here. How can we turn this into a multiplier? Well, what we do is just bring this up to here. So we see that delta Q over Q let's just put equals E times, oh no, hang on, E times delta P over P. Okay, so what does this mean? Right, this is the relative change in price. This is the relative change in demand. So it is a multiplier, right? Elasticity is the multiplier which turns relative change in price into relative change in demand. So if E equals 1, that means if you change the price, you can have the same change in demand. So if the elasticity is 1, that means if the price of the good goes up 1%, demand falls 1%. If E is less than 1, like for example we saw for milk, so oh hang on, we should figure out E for our goods here. Okay, E here it's 1% divided by 2.5%, which is 0.4. Here, minus 10% divided by 2%, absolute value, we get elasticity of 5. Okay, so elasticity of 0.4 tells us that if we have a change in the price of milk, the demand changes by 40% of that. All right, so if the price of milk goes up X, then the demand for milk goes down 0.4 times X, but as a percentage, right? So if the price of milk goes up 1%, the demand for milk drops 0.4%. Okay, so that tells us that milk is a good. Does that make sense? Because basically, if you're a milk drinking family, right, you always have milk. And so if the price goes up, you're only going to change by a little bit. You might economize a little bit, but you're still going to buy milk. Whereas for a truck, we've got elasticity of 5, which means if the price goes up 1%, the demand drops 5%. It's much more sensitive to price change. Why is that? So Ford, say, increases the price of his trucks. What happens?
Less people will buy them. Less people will buy them.
Less people will buy them, but what, they're going to go to, I don't know, what is Ford trucks? What's the other one? Ram or whatever. They're going to, there's a market for trucks. So even disregarding the fact that people still want their trucks, but people will kind of go and will try another brand of truck. If all the trucks rise in price, you're still going to get a fall in demand, but that's because people are going to hang on to their truck for an extra year or whatever happens. Whereas milk, not many people are going to switch to almond milk or rice milk or whatever. Okay, they're going to want their milk. So this, okay, so you kind of see why this is a useful idea in economics. It really, if you understand the idea of elasticity and you know what these numbers are, you really understand the market. You really understand what's happening within the market. So is this the kind of stuff that you did in micro? Okay, good. So actually, I should put a minus sign here, right? Because price and quantity are always negatively linked. Okay, so we can see that kind of E equals 1 is kind of like a dividing line between two kinds of goods. So we've got these kinds of goods where changes in price are not going to cause much change in demand. And we've got goods like this where changes in price is going to lead to big changes in demand. Okay? And it all depends upon what the value of E is. And so hopefully you can see where the term elastic means, right? So what does elastic mean? So something being elastic means it kind of stretches a lot, right? And so we can see this kind of like happening for the good. So actually, which is more elastic? This one is elastic. We think of it being elastic, right? So things are really being stretched out. So a little bit of change gets stretched out to a big change. So these kind of goods are called elastic. And these kind of goods where it's kind of stiff and it resists, right? So a change is only going to change a little bit. This is called inelastic. So that's another basic thing. So if E is bigger than 1, we call it an elastic good. E less than 1, an inelastic good. Okay, so let's have a look at a couple of examples. Let's see if I can download something. Okay, so here's some examples of some goods. So, and for some reason, I didn't put the butter in properly. Okay, so here are some examples of some goods. So just ignoring butter. So we see that all these goods here, cabbage, potato, wool, peanuts, egg, milk, oranges, cream, are all inelastic goods, which means that as the price increases, it's going to have very little change on the demand. Here, apples, peaches, tomatoes, lettuce, peas, we see inelastic. Now, is a good always going to be elastic and inelastic no matter what the price is? So think about cabbage. I know, did anyone ever go shopping for groceries? So if you ever go to the grocery store, you'll see that cabbage is quite typically the cheapest vegetable there is. We see that it's pretty inelastic. So is that because, why is that? Is it because people just got to have their cabbage?
That's so cheap.
It's so cheap, right? So it's so cheap, it's like, it's actually really cheap. So if it goes up 5 cents, it's still really cheap. So people are just gonna, if you've got a recipe for, you need cabbage, I know it's what, St. Patrick's Day, and you're having cabbage and sausages and potato or whatever, you're still gonna buy it, right? Where other goods are much more sort of sensitively priced. So for example, apples and peaches and that, if you think about it, you're going to buy your fruit, apples look good, and they're cheap, okay, so I'm going to buy some. But if they're expensive, maybe I'll buy oranges or peaches or nectarines or whatever. So it's not only the good itself, but how the good is positioned within the market. So this elasticity gives us kind of lots of information about the market. Okay. So here was our example. We figured out the elasticity of those. Let's do another example. Okay, so let's say we have a hotel. And at the moment, our price is $75. And at $75, we can rent out 100 rooms. And let's say from experience, we know that if we sell the rooms for $80, then we're going to get 90 rooms booked out. Okay, so let's think about, should we do that? Okay, so if we've got a hotel, basically what we want to do is we want to maximize our revenue, right? Because we want our hotel to be full up. But we want to get as much, our costs are usually pretty fixed. Doesn't really matter that much how many rooms. So let's have a look at revenue. Oh, this is easy. So we get 7,500. We do that. If we do $80, we're going to get like $7,200 in revenue. So it looks like raising the price, it looks like a bad idea. We get more money per room, but we're renting less rooms. Okay, let's have a look at what the elasticity is. Okay, so the elasticity is what? Let's think about this. It's delta Q on Q divided by delta P on P. So delta Q was right. We got down $10 on 100, right? So we're selling 10% less rooms. How much did our price change? So our price changed $5 over 75. So if we go ahead and do this, this is going to be 5 goes into that 15. So what is it? It's 10 times 75 is 750 over 500. So it's 1.5. So here we are in an elastic situation, and so we kind of see why this was a bad idea, right? That because a change in the price had an exaggerated effect on demand. So when we're in this kind of elastic situation, we've got to be really careful about rising prices, because revenue is going to fall. Okay, now why would that be? Well, let's have a look at the revenue function. The revenue function is P times Q, right? So we know how to optimize something. We take its derivative and set it equal to 0. So marginal revenue equals what? So we're going to take the derivative with respect to P. So it's equal to P times dQ dt plus the derivative of P is 1 plus Q. So at the critical point for revenue, what happens? Well, P times dq dp equals minus Q. So then if we divide by Q, we get P divided by Q times dq dp equals 1. But that's just elasticity. So the situation where elasticity equals 1 is the critical point of the revenue function. So basically, if you want to maximize your revenue, you sort of increase price until you get to that critical situation of E equals 1. That's if you want to maximize revenue. Of course, that might not be the best thing for your business, right? Because of course, the best thing for your business is to maximize profit. So we know that revenue, and we just can't maximize revenue and expect to maximize profit. Okay, so but that gives us a good kind of good test then whether to raise prices or not. Let's okay, so I've given you numerical examples, so let's do a formula example. So a formula example would be if I give you a demand curve. So let's say our demand curve is Q equals 1,000 minus 2p squared. So let's find E. Okay, so since we've given a formula for demand, we'll now have a formula for elasticity. Okay, so demand, so elasticity, remember, is dq dp times P divided by Q. So dq dp, right, is what? It's minus 4p. P is P, and Q is 1,000 minus 2p squared. So it's equal to 4p squared, absolute value takes care of the minus, over 1,000 minus 2p squared. So we've actually got a formula for elasticity. So I could ask questions like, what's the elasticity when E equals $10? Well, then I just do 400 over 1,000 minus 200 equals 0.5. What's E of $15? Again, I put it in. 15 squared is 225, I believe. 225 times 4 is 900. 225 times 2 is 450 over 550. Okay. It's great, some quantity bigger than 1. Okay, so we see that at $10, our good is inelastic, and at $15, our good is elastic. So this then again just emphasizes the fact that elasticity not only depends upon the good, it depends upon what the price of the good is. Every good becomes inelastic if it's cheap enough, and every good becomes elastic if it's expensive enough. Okay, so we can ask, well, where does E equal 1? When E equals 1, that's where we're going to maximize revenue, and that's going to be when 4p squared equals 1,000 minus 2p squared. So 6p squared equals 1,000. So p equals square root of 1,000 divided by 6, whatever that is. So that's 500 divided by 3, which is like around square root of 167, whatever that is. It's around 13. We already knew that, right? Because we knew it was between 10 and 15. And so, because of this, because we know about the connection between revenue and elasticity, we can answer some questions kind of straight away. So, for example, let's say the quantity demanded when the price is $10 is 300. So let's say we have a price increase of $1. What's going to happen to revenue? Okay, well, a price increase of $1, right, it's asking what happens when there's a 10% increase in the price. Let's say we're dealing with a good where, say, the quantity goes down, let's say 10 units. What's going to happen? Well, 10 divided by 300 is around 3%. Okay, so if the price increases 10% and the quantity demanded goes 3%, we can say straight away revenue is going to increase. Without having to do any numbers at all, just because we see that it's an inelastic good. Whereas if the quantity goes down 100 units, straight away without doing anything, we're going to see that revenue is going to decrease. Right, because 100 divided by 300, right, that's like a 33% compared to 10%. Okay, excellent. Okay, so we had a look at this slide. So this thing here in bold, okay, so there's two things you need to know. You need to know the definition of elasticity, so you need to be able to compute that. And this is the the facts that you need to know. You need to know the relationship between the elasticity and revenue. So you just need to know that. Okay, so here's a nice complicated question for us. Whose turn is it? Who's on top? Elijah, you're on top. Oh, that's right. I know why you're on top. Anyway, let's have a look at this question for you. An item currently sells for $10 per item. A producer finds that increasing the price to $11 per item has almost no effect on demand. Which of the following things is true? Which one of those do you think?
I don't think I know.
Okay, so the price goes up, but demand hardly changes. Is that elastic or inelastic? Inelastic. Okay, so A and B. Okay, will you get more revenue or less revenue by increasing the price? You're going to get more because of the inelasticity, right? So even if you sort of don't know this by heart, you should still be able to kind of go through the motion. It might take you a bit of time, which you don't want to waste on a test, but you should be able. It should be common sense. So it's A. Is the example right there. Hannah. Okay. You've got a choice of two. We've got a delinear demand curve. At which price is the elasticity going to be greater? At the higher price or the lower price? Yeah. Okay. If the price is high, you're going to be a more discerning shopper, and you're going to be more likely to not buy it, right? If the price is too high. That's just, again, it's common sense, but you should be able to figure it out from the idea of elasticity. Okay, doke. That's us for today.